All right, so in this lesson, we will learn about solving absolute value equations, solving equations involving two absolute values, and identifying special solutions of absolute value equations. So an absolute value equation is an equation that contains an absolute value expression. You can solve these types of equations by solving two related linear equations. So let's just talk about some properties of absolute value very quickly. So this first one just basically says the absolute value of any number is always going to be at least 0. It can never be negative. And that's because the absolute value is just the distance away from 0 on a number line. That's how you can think of it. And we can't have a negative distance. This, number 2, is basically just saying if you take the absolute value of a number, that's going to be the exact same as the absolute value of the opposite of that number. 3 says if I take the absolute value of A times B, that's the exact same as taking the absolute value of A times the absolute value of B. And then the same works for division here, or the fraction. The absolute value of A divided by B is the exact same thing as the absolute value of A divided by the absolute value of B, and we cannot have B equal 0 because we cannot divide by 0. And to solve an absolute value equation, we're basically going to turn it into two related linear equations, and I will show you guys how to do that. I call this unwrapping the absolute value. That's not an official term, that's just my terminology here. And right here, when C is less than 0, in this case, there's no solution because this whole thing in the absolute value cannot be less than 0. And if C is negative, that means it is less than 0. So we're saying a number that is not less than 0 is equal to a number that is less than 0. That's obviously false. So we'll see some of that as well. Solve each equation, graph the solutions if possible. So here I have the absolute value of x minus 4 is equal to 6. So what we can think of this is we need this thing inside the absolute value, x minus 4, to be equal to whatever numbers will be true if you put them in the absolute value to get to 6. So there's two possibilities here. The absolute value of 6 is 6, and the absolute value of negative 6 is 6. So I need to set x minus 4 equal to both of those numbers. So this is what I call unwrapping the absolute value. I'm going to rewrite this as x minus 4 equals 6, and x minus 4 equals negative 6. Okay? So now I just solve these equations, and luckily you can solve them the exact same way. So I'm going to add 4 to every side, and then I get x equals 10 and x equals negative 2. So these are my two solutions that if I plug these back in, if you look at this, 10 minus 4 is 6, absolute value of 6 is 6, good. Negative 2 minus 4 is negative 6, absolute value of that is 6. So we know that both of these are true. Now graph the solutions if possible. That means on a number line. So I'm going to draw a number line. This is very rough, but hopefully you get the picture. And I'm just going to put my values from left to right in order. So let's say I have negative 2 here and 10 here. Okay, my values, now you could put them on the number line. So maybe I'll do that and use a different color. So here's one of my values, and here's the other one. Okay. Now, if you don't want to do this or don't have different colors, you can put them above instead. I'm fine with that. But obviously, if I'm not your teacher, just check with your teacher to make sure that that is okay. So anyway, that is how to solve the first one. For part B, I see I have the absolute value of 3x plus 1 is equal to negative 5. Let's just look at this before we try to solve it right away. The absolute value of 3x plus 1, this has to be at least 0. So 0 is the smallest thing that can come out of here. Everything else besides 0 is going to be positive. Well, we have this equaling to a negative number. So this basically saying something that can't be negative equals negative 5. Well, that's obviously not true, so I don't have to do any work here. I know this is a no solution case. There's no value of x I can plug in to make this true, which is why it's no solution. So now we're done. All right, solve. Absolute value of 3x plus 9, all minus 10, is equal to negative 4. Well, whenever we have an absolute value equation, the first thing we want to do is treat this whole absolute value expression like a variable. We want to isolate the entire absolute value expression. So to do that, I see that this whole expression is being we're subtracting 10 from it. So to cancel that out, I'm going to add 10 first. So now I have the absolute value of 3x plus 9 equals 6. And now I see that I have an isolated absolute value expression. So once my absolute value expression is isolated, I can unwrap it. And remember, when I say unwrap it, I mean I can write my two equations that correspond with this absolute value equation. So I'm going to rewrite this as 3x plus 9 equals positive 6, and 3x plus 9 equals negative 6. Because remember, if this whole thing in the absolute value is negative 6, the absolute value of negative 6 is positive 6, so that would make this equation true. So anyway, now I just want to solve both of these equations, and luckily the steps will be the same. We'll get different values, but the steps will be the same. So I see that I have a 3x and a plus 9, same thing here. So I want to get rid of my addition before I get rid of my multiplication. So I'm going to subtract 9 on every side. I'm going to scroll up here a bit. So I get 3x equals negative 3 here, and then I get 3x equals negative 15. Now I see that 3 is being multiplied by x. I'm going to divide every side by 3. And you don't have to solve both of your absolute value equations at the same time, and I'll just draw this little dashed line to show that these are my separate equations. But I find that since the steps are going to be the same, might as well do them all at the same time. Anyway, I have x equals negative 1, and then here I have x equals negative 5. And just to check our answer, we can plug both x equals negative 1 and negative 5 into our original equation. So I could plug in negative 1 here. I get negative 3 plus 9 is 6. Absolute value of 6 is 6. Minus 10 is negative 4. And then for negative 5, excuse me, you get 3 times negative 5, which is negative 15, plus 9, which is negative 6. And the absolute value of negative 6 is positive 6. Minus 10 is also negative 4. And one other thing, anytime you have multiple solutions of an equation, you can rewrite it just as something like this: x equals negative 5, comma, negative 1. This would be the same exact thing as these being your two solutions. I typically like to have them in numeric order, but either way, whatever way you prefer is fine. In a cheerleading competition, the minimum length of a routine is 4 minutes. The maximum length of a routine is 5 minutes. Write an absolute value equation that represents the minimum and maximum lengths. So what absolute value expression can I plug 4 and 5 into to make it a true equation? So anyway, what we want to do is we basically want to find what number is right in the middle of these two numbers. So 5 and 4, the number that's in the middle of that is going to be 4.5. And then we want to find the distance between that. So if we add 0.5, we get 5, which is our max. And if we subtract 0.5, we get 4, which is our minimum. All right, so now how can I write that as an absolute value equation where I'm solving for x, which x is the boundaries. X is the minimum and maximum length. Well, if I take this 4.5 away, so if I do the absolute value of x minus 4.5, so x minus the middle value in between these two boundaries, okay? And then if I set that equal to the how far it takes to get from the middle to the maximum or to the minimum, so I'll set this equal to 0.5, this is actually going to work out, and I'll show you why. So I'm going to unwrap my absolute value like I have been doing in the past examples. So I get x minus 4.5 equals positive 0.5, and x minus 4.5 equals negative 0.5. And then I will add 4.5 on both sides. And here, not 5.4, 4.5. And here, you'll see that I'll get x equals 5, which is our max, and x equals 4, which is our minimum. Okay, so this might not be all too obvious on how to do this, but basically all you got to do is take, for one of these types of problems where you have a maximum and minimum value, find your value in the middle, and then do your variable minus that value in the absolute value, and then set that equal to the distance from the middle to the boundary, and then this will be your equation. So that is how to do this example. So here's another core concept. If the absolute values of two algebraic expressions are equal, then they must either be equal to each other or be opposites of each other. So in this case, we have a lot of variables, but it will make sense in just a moment. To solve the absolute value of ax plus b equals the absolute value of cx plus d, solve the related linear equations ax plus b equals cx plus d, or ax plus b equals negative quantity cx plus d. And in this or, it means that only one of them needs to be true, and means they both would be true. We're assuming or for all of our solutions in this case. So I'm going to unwrap this a little bit and show you the reason why this is the case. So if we had absolute value of ax plus b equals absolute value of cx plus d, well, if I just look at this side first, I would want to unwrap this side. So I'd rewrite this as ax plus b equals positive absolute value of cx plus d, and then ax plus b equals negative absolute value of cx plus d. Okay? Well, now I want to unwrap both of these things. Okay, so here I would write this as cx plus d equals the positive ax plus b. And I'm just going to write the next one below because I'm not going to solve these. And then to finish unwrapping this, I would also need that cx plus d equals the opposite of this, negative quantity ax plus b. Okay, and then over here, I would want to get rid of this negative sign, so I could divide both sides by -1, or just basically the same thing as just changing this negative sign to over here. And then to unwrap this, I'd say cx plus d equals just the way it is negative quantity ax plus b. And then over here, I get cx plus d equals the opposite of this, but the opposite of negative is positive. So this is ax plus b. So we've completely solved, I'm using my air quotes here, solved this. We've at least unwrapped this right here. And these are the 4 equations that we have. But if you notice, up here we only have 2 equations. We have ax plus b equals cx plus d, or ax plus b equals negative cx plus d. Well, if you look, this equation is the exact same as this equation. They're identical. And then this equation is the exact same as that one right here. So these are the same. So the reason why you only have to do these 2 equations is because if you did all 4, it'd be redundant. And if you notice, this equation right here with the negative sign on the left side is the exact same as this equation. If you divided this equation by -1, or multiplied by -1, or took the opposite of both sides, you get this exact same equation. So anyway, the only reason I wanted to explain that is to show you why that when we have 2 absolute values, we just need to unwrap really one side, and we can ignore the absolute value on the other side. All right, so for part A, I have the absolute value of 3x minus 4 equals the absolute value of x. So I can just rewrite this as 3x minus 4 equals x, and 3x minus 4 equals negative x. So I am going to solve this equation first. I'm going to subtract, well, actually I'll solve them both at the same time. Subtract 3x on all the sides. So now I get negative 4 equals negative 2x. Here I get negative 4 equals negative 4x. So now I'm going to have to solve these equations separately. So in this case, I have negative 2 times x, so I'm going to divide by negative 2 on both sides to cancel out the multiplication. So we get x equals positive 2, which is one of my solutions. And then I need to divide by negative 4 over here. So I get x equals 1. And these are my answers. You can always check to make sure that you get the correct answer here. So if I plug in 1 here, I get 3 times 1, which is 3, minus 4, which is negative 1. Absolute value of negative 1 is 1. So this is going to be true. And then same thing here. I would get 3 times 2, which is 6, minus 4 is 2. And the absolute value of 2 is equal to absolute value of 2. So we know that that's correct. Now I'm going to do this other one over here. So we have 4x minus 10 equals 2 times 3x plus 1. All right, so to solve this, we're going basically choose one of the sides to unwrap, which will help us unwrap both sides. So I'll rewrite my equation as 4x minus 10 equals 2 times 3x plus 1. And then my other equation is going to look like this. I'm going to zoom out a little bit so we can have both. It's going to be 4x minus 10 equals negative 2 times 3x plus 1. Okay, so first thing I'm going to do is distribute. So I'm going to bring this down. 4x minus 10 equals 6x plus 2. And then 4x minus 10 equals negative 6x minus 2. Now my equations are slightly different, but I'm going to solve the same steps. So here I'm going to get rid of this 6x, and over here I'll get rid of the negative 6x. So I'm going to subtract 6x here and add 6x here. So I'm going to get negative 2x. Here I'm going to get 10x. And then in the same step, I'm going to add 10. Okay, so when I add 10, these cancel. Bring the equals down. These cancel. And I'm going to get 12 here. And then I'm going to get 8 here. All right, so now we just have to solve the single step equation. So I'm going to divide by negative 2 here. Divide by 10 here. So I'm going to get x equals negative 6 and x equals 4/5. And you can have this 4/5 in a decimal form if you like. But anyway, you can plug these back in to check yourself. But that's how to do that one. All right, so we're going to talk about special solutions. When you solve an absolute value equation, it is possible for a solution to be extraneous. An extraneous solution is an apparent solution that must be rejected because it doesn't satisfy the original equation. Okay, so a lot of times you'll see an extraneous solution if you have an absolute value expression with a variable inside of it on one side and then a variable expression without an absolute value on the other side. But anyway, let's just see what it looks like. So to solve this, I'm going to unwrap my absolute value expression. So 2x plus 12 equals 4x, and then 2x plus 12 equals negative 4x. Okay, so now I'm going to subtract 12 on both sides. So now I'm going to move my 2x term on the other side, so I'm going to subtract 2x on both sides. And now I get 12 equals 2x over here, and then 12 equals negative 6x right here. Last step, I'm going to divide 2 here and then negative 6 here. Once again, you don't need to do your two equations at the same time. I find it easier, but if you think it's easier to do it another way, that's how you can do it. Divide 2 here, divide negative 6 here. Okay, so now I get x equals 6. And then here I get x equals negative 2. So when I look back up at my original equation, I'm just going to check my answers. So if I plug 6 in, I get 2x, so that's 2 times 6, which is 12. 12 plus 12 is 24, absolute value of 24 is 24. Over here, I get 4 times 6, which is 24. So I know that this value for x, 6, works. And then over for x equals negative 2, let's try it. I get 2 times negative 2, which is negative 4, plus 12 is 8. Absolute value of 8 is 8. But over here, I get 4 times negative 2, which gives me a negative value, which means it can't be anything. It's going to be negative 8. Negative 8 does not equal 8. So this is not a true statement. So this is an extraneous solution right here. So my only value is x equals 6. This is extraneous. And that's how to solve that problem and identify extraneous solutions. So here we have the absolute value of x plus 5 equals the absolute value of x plus 11. So let's just do our same thing. So I'm going to unwrap. I get x plus 5 equals x plus 11. And x plus 5 equals negative quantity x plus 11. Okay, so I'm going to solve these equations. First, I'm going to distribute this negative. So I have negative x minus 11 equals x plus 5. And now over here, I see something a little fishy. I'm going to subtract x on both sides. and I get 5 equals 11. Well, I know that this is not going to work because 5 absolutely does not equal 11. Okay, so I know that this is going to give me something that's useless right here. So let's see if this works. First, I'm going to move this negative x term. So I'm going to add x on both sides. So I get 2x. And then I'm going to subtract 5. Make that x a little bit better. So I get negative 16. Okay, so we get 2x equals negative 16. Divide 2. Get x equals negative 8. You can check it. And if I plug in negative 8 here, I get the absolute value of negative 3, which is 3. Here, if I plug in negative 8, I get the absolute value of 3, which is 3. So 3 does equal 3, so I know that this does work. And then this one obviously won't give us anything.